I think we're live. Audio's working, chat is working, everything's working. We just tested the alerts as well. Thank you, Christopher, for the follow. That was great. So I got like 40 something followers from the post on the Rust subreddit. That's cool. Welcome to the stream, guys. So for those of you who watched last week's stream, we were doing some stuff on the project here. So if you're familiar with GraphQL, there's this library for Rust called Juniper, which is basically like a GraphQL server library kind of thing. But what I noticed that it was kind of missing, let me show you how it works. They have this this book that describes how it works. It's basically a bunch of macros. Funny objects. Yes, so they have this like GraphQL object macro that you can use that then defines how your Rust struct maps to a GraphQL object. But what it doesn't allow you to do is have like an actual GraphQL schema like this. So what I wrote is I wrote this Juniper from schema crate, which is basically a procedural macro that uses another of the Juniper project's crates, which is just a parser for GraphQL stuff, to parse the schema and then generate all these like macro calls that you would otherwise write yourself. And then it makes some traits that it just calls from within these methods. And then these are all these like field traits that you see here that you then have to implement. So what we did last time was there's some special sort of code generation going on for these things that I call query trails. Query trails is sort of a type-safe way to ask, like, so in GraphQL you can query for basically whatever you want, which means that if you're not careful, you might make lots of expensive database queries that, like, if you could introspect the whole query up front, you would you'd be able to make smarter queries. So this is what this query trail does. It allows you to sort of ask like which queries or which like parts or which objects are basically being queried sort of later down the road, and then you can make smart decisions about it. However, I noticed that there was a bug that this stuff didn't get generated correctly if you used GraphQL interfaces and union types. So what we did last time, if we just open the test, was we wrote this test where we have so we have sort of a dummy interface just called an entity that just has like properties that make sense for us to test. It doesn't necessarily make sense in the real world. And then we just implement that for a user, and then we test that down here we test that we can actually use these like introspection methods correctly. So this is sort of what we did last time. However, we hit a bit of a roadblock when we tried to implement it for union types. Basically, the code didn't want to compile because there was some error in the Juniper macro that we used, and it didn't give us any way to debug it, basically. So we basically we copied this example directly, and that didn't even compile. Let's just make sure that it still doesn't compile. But what we then did at the end of the stream was we, you see this is the type that we got before, cannot infer type. And like we have no idea where this even comes from. So what we did last time was we made an issue on the repository for Juniper. And they have since then responded. This is the one with a fix. So we're going to try and apply that. And if it works, then hopefully we can make progress. Basically, my question was, my question was that I wasn't quite sure how to generate the methods for the query introspection stuff for union types, because it's sort of, because we're not dealing with like one type, we have several types that might have different fields. So what I thought you might want to do is say that even though you're only returning a human, if they're still saying like, if I get a droid, then the primary function, then even though, like, if this makes sense at all, otherwise just ask, like, when you then evaluate that query, you only find a human. Would you then, if you asked, if they're asking for the primary function, would you then get a yes and then do some work if you found a droid but you didn't? I wasn't quite sure how to handle that. I figure, so I figured what we were going to do is just check how does Juniper do it, and then just emulate that behavior. Because what our query trail stuff is basically a wrapper of is this thing called lookaheads. A lookahead, if I can type. So on the executor, which is like the object that is sort of in charge of evaluating your queries, there's this lookahead method, which returns a lookahead selection, and this implements a trait called lookahead methods, which is what allows you to ask, like, is the name of this thing coming up? And then you get another thing that implements lookahead methods that you can then call select child on again. So this is sort of how our query trails work under the hood. Whoops. So we're just going to experiment and see, like, what does this actually return, and then try to emulate that. Does that make sense? If something doesn't make sense, just post in the chat and I'll see if I can explain it better. So this should compile. Great, that's step one. So now we need to somehow like get this set up so we can actually like run some queries, use this introspection stuff, and then we'll see what it returns. So one thing that we're definitely going to have to do is use this trait. And I believe they have like a complete example of like a quick start thing of actually running some queries. Yeah, so context. Let's remove these comments. Episode doesn't exist. So what we're doing now is basically getting the data set up. New found for root node. Why not? Root node. Trip-bound query GraphQL type. So we have this. So this query thing is like the root of our GraphQL query, but we haven't actually made that into a GraphQL object yet. So let's just do that. So this is another reason that I wanted somehow to avoid having to use the macros, because Rust format doesn't support macros. Like if we smash it onto one line, and all of this, you'll notice that it's only the bottom one that gets formatted. Rust format doesn't know how to format this, which is just kind of annoying. So now it compiles. Let's see if we run it. Alright, it finishes and there's an assertion at the bottom, which means it works. Let's just for good measures print it. Oops. Nightbot is going crazy. I guess I have to set up some sort of spam filtering. I basically just took the default Nightbot setup and just used that. Sorry, Christopher. Yeah, this works. Then what I figure we can just do is make one. So for the episode, what if we nuke the episode type and we instead put in a character human. A human has a home planet Earth. Christopher, did you just subscribe? You're my first subscriber. That's amazing. Thank you so much. I have to see this. Sorry guys, we're watching our own stream here. How does this work? Give this up. Subscriptions. So it's very clear that I'm new to the whole Twitch thing. But thank you for subscribing, man. That's fucking crazy. First subscriber. Where were we? Yeah, so these need to be strings. Into. So I basically want a field that returns a character so that I can actually introspect what happens. Character. And then we can say ID, right? No, we have to use like GraphQL stuff. Character. What's the syntax? Droid ID. I think this is right. Nope, some silly syntax error. Is that not how you make multi-line strings in Rust? Or is it like this? I thought you could make triple quotes. Is that not a thing? Maybe we just... Did we just forget this comma? No, we did not. Cannot move out of borrowed content. Perfect. Can you borrow here? Nope. So we're not interested in like doing it correctly. We just need data. There we go. This compiles. Let's see what it returns. It might just blow up. Yep. Can we print it a bit nicer? Nope. God damn it. Pretty print. Yeah, so I learned this like a week ago. So you have, for Rust format strings, you have this way, which uses like the display trait and is sort of for like human readable printing. You can do this way, which is uses the debug trait, and it's just sort of for debug output that's not necessarily human readable. And you can use this syntax, which is the same as debug, but is somehow pretty printed. So you can see here, this is smashed all into one line. If we run this one, it should be a bit easier to read. Unfortunately, it is not. That's because it's a panic. So we don't even get to here. It somehow dies beforehand. But hopefully later, when we get here, you'll see. It's classic. Have you guys ever like tried to fix a compile error or a test failure or something like that for like an hour, only to realize that you were looking at the wrong file the whole time? I do that a lot. So what is the actual error? Field home planet for human. Unknown field primary function for droid. Yes, that's probably because it converts all the fields to camel case. Oops. Yes. So here you see, this is the pretty printing that I was talking about before. Can we use... No. So it is... it does look right. Yeah, we get the ID that is 1, and the home planet that was Earth that we put in before. Cool. Then let's look at the look ahead stuff. How did you actually use it? So you say look ahead. Let look ahead. Executor look ahead. And then you can say select child as child argument. I'm wondering if, like, does that mean that we now have access to these fields? So if I say home planet, this is one of those Rust things that I don't quite understand. So it's complaining that we make a temporary variable and then we somehow borrow from it later. And I think what you sometimes have to do is you just have to make a local variable that then exists for this scope, and then that makes the borrow checker happy. See, that was it. That's just Rust, I guess. Okay, let's remove this guy. Now let's just make it print less. Home planet, alias none. Can we just inline this? Because then we can query for some more. Just let's try something that doesn't exist and see what we get. We should get a none or something like that. Yeah, we do. So that's, whoa. That's the second one. And then if we query for something that is only on the droid, we should get that as well. We do. Okay, so basically how it does is it sort of takes like the set of all possible fields, right? So now my question is, if we have like nested resources, if we had like a planet planet that then had a name. Can we then ask for the planet as well? So what if the home planet, what if that was its own resource? Let's do that. First of all, this query should fail because home planet is a string, not a like its own type. And it does. Field home planet must not have selection since type string has no subfields. Makes sense. Let's make it planet name, and we just have to insert that here. Planet name Earth. Let's use into. We can also you can also use toString here, which should work, but I just prefer into because it's shorter. And it has no overhead because like that stuff is inferred at compile time exactly which method to call. Let's bring back our stuff from before. So we get it, and it has a child, which means that we should be able to say unwrap, select child name. We can't really format it. Let's just do this to keep our sanity. Yeah, so this definitely works. So what it's doing is taking the combined set of all the possible attributes, and then returning that. So that is what we somehow have to emulate. The very first thing we need to do though is write a test for it. And at first, let's just make sure that the tests actually pass. I ran it just before the stream, so they should work. Great. Let's also make a new branch. I have, as you've probably noticed already, a bunch of like shell shortcuts. So CA is just cargo. And then the way that cargo works is if you have a command called cargo dash something, then you can run that as like cargo B, and then it'll like look for a command that's actually called cargo B. That's how, if you see all these like cargo readme, for example, like if you see all these libraries that add new subcommands to cargo, that's exactly how they work. They just install a binary called cargo dash something, and then cargo will discover it. So what I have is I have an alias, CA is alias to cargo, and then I just have a bunch of these like cargo B for build, C is check, and T is test. So then I can just do CAT instead of like cargo test, which is like very little setup for saving a lot of keystrokes in the long run. So like as you can see, I have a whole bunch of shell aliases for lots of things, and in particular like Git stuff and so on. And all of my .dot files are all on GitHub if you're interested. .dot files, like they're all here, including my my Vim config. All right, so the test passed. Let's make a branch. Git checkout branch. Query trails for union types. Query trails for union types. So these tests are kind of funny. As you see, there's no assertions. And the reason is that what we're testing is this procedural macro, the GraphQL schema macro. So the macros in this library comes in like two flavors. there's the GraphQL schema and the GraphQL schema from file macro. And so this macro, you can basically write the schema like directly in your Rust source, which I would not recommend you do unless you're like writing these sorts of tests. The macro that you actually want to use is this one that just takes the path to a file. So like this. However, like this macro is really helpful for testing, because then we don't need separate test and separate like Rust and schema files all over. So what I think we're going to do is just convert this interface into a union type. Because interfaces and unions are sort of very much related. The difference is that with a union type, you declare upfront which types it can be. Whereas for an interface, you can just add a new type and then also implement that interface. So let's see what the syntax is. Let's say that we have an entity that is always a user. I think that is it for now. And then to actually do so you'll notice that up here we have on the post, so the post, the root object, the query, has a field called posts that just returns a list of posts. The posts then have comments, and the comments then have an author entity. So what we can do is, like when we're down here and we're evaluating this author field and have to return some entity, we can say, since the previous example was an interface, we can say on this query trail entity thing, are we asking for the ID? And so this method will return a boolean, since this is a scalar field, it doesn't have any subtypes or subfields. Whereas if we say country, then it basically returns a query trail for the country, and then on that query trail we can say ID to see if that is loaded. So we can sort of chain these these look-aheads, and then when we're done and we've built up the entire thing, then we can actually run it and see if the whole thing is there. So you'll notice that that's different from what we had to do here. We have to say get the child and then unwrap it and then get the next one. If we wanted to do further chaining, we'd have to unwrap again and then call select child. And the reason that Juniper has to do this is because like these queries, or rather the schema, they don't have the whole schema up front at compile time. So they can't make these methods up front. Whereas we can do that over here because we have the whole schema at compile time. So what it basically does is it goes through the whole schema, finds all the types, and then it generates. So you'll notice that query trail has two generic parameters. So it just generates methods for query trail, some lifetime A, and then each of our types here. And then this walked thing, you don't need to worry too much about that. So it just does this for each of the types, and then for each of its fields, it just returns another query trail with the return value of this field. So that's sort of how that works, but we'll get more into that when we actually jump into the source code. So let's close this one. So right off the bat, like this should work if we just do this. And to stay sane, I'm just going to comment out all the other tests. Otherwise, we're going to get a whole bunch of warnings and we might get debug errors and stuff like that later on. So that works. And just to verify that it is in fact the union that we made. There it is. There's no more interfaces. Then if we bring this in, it should fail to compile now. Yeah, and it does. So no method ID exists for some long module name, query trail, entity. So this is the method that we have to generate. Yep, and that one fails as well. So what we have to ask ourselves now is, I'm just wondering, is this even gonna work? Like, what if this one could also be a let's try adding a second resource and then think a bit more about it, because I'm thinking we might gonna get into like type issues. Since, so if you imagine you call query trail country, that would return like country. Not walked. Not sure. Not walked. And then on that one we can call ID, right? And if we imagine we had a second one, like an entity could also be, well, I don't know, a company. A company could then have a boss. Like, what would that be? That would then be some user, suppose. But what if both user and company have a country? What do we then return here? Or if they both have. No, a name is fine, because like name would be a scalar type that just returns a bool. So that will work. But you could imagine that like both a user and a company would have a country. What would it do? Yeah, and the issue is that if they have the same name, but they are different types, that would be weird. Why would it have different fields, like fields with the same name but different types? Is that even a thing that we want to support? What do you think, chat? What should we do? I suppose. So if the fields have the same name and the same type, then that's fine. If they have the same name but different types, that doesn't work. And if they have different names, that also works just fine, because then the methods are different. And I suppose that in the case where they have different same names but different types, I don't think we can handle that unless we return like an either thing here. Right? But this is, I'm not sure if I'm overthinking it or if, but basically what I'm thinking that we'll have to do is detect that that this is like this is happening, same names, different types, and then just give an error at compile time and be like, you can't do that. If any of you guys are watching who has a good name, a good idea how to fix this, just let me know. Because I think we'll have to count that as an error. Let's write a note to ourselves. Same field name, different types should not compile. I'm always worried when I leave these to-dos in the bottom of the file that I will eventually see them. But you guys will help me out, right? So this compiles. No, it does not. Do we break it? Oh yes, we added the company. Cool. Let's add a. Yeah, let's do that. Let's add a new entity that's a company. No, let's get this working first, and then we'll expand the test to actually have different types. So I'll go over it briefly. We also went over it in the last stream. Basically, the way it works. So here's the one procedural macro Procedural macros are just sort of functions that takes some tokens and returns some tokens. So it's basically a function from Rust code to Rust code. It's pretty simple. Then you just annotate it with the special macro here. And so this is the other macro that we have, GraphQL schema, and they eventually call this function that takes the schema, then parses it, and then it does a bunch of processing, and then it just spits out the final stream of Rust code at the end. And you'll notice that one of these methods is gen query trails, which lives in this walk.ast module. Whoops. That is just a re-export from this module here. Query trail. So this is the case that we added before. It basically loops over all the definitions in the schema, and then if it sees a type definition, which is that's stuff like this and this and this and this one, then it just does stuff. And we only really care about the objects, which are these, like type, and the interfaces. That's the one that we added last time. So we're going to have to add another one here for unions. Let's, as the first thing though, let's just look up the documentation for it. GraphQL parser. And then it was type definition. So you can see that the main function that we care about is this parse schema that gives us maybe a document that has a list of definitions. That's the field that we access here. And then a definition is maybe a type definition. That's the one we care about. That's this guy. And here it is, union. Union. Let's just make sure that things are wired up correctly. So if you panic from a procedural macro, it just appears in your output as as a message like this, and it seems that we are actually hitting this, so that's good. Not implement a union. Let's see. Let's look at the type first. What does a union type have? It has a list of named types, which are just strings. Some directives, description, name. We don't really care. We need the name and we need the types. So what we basically need is we need to loop over all these types, and then for each type we need to find all their fields and their types. So what this method that basically does the heavy lifting does is it gets, like what we just talked about, it gets the name, which then is the second or the first generic parameter here, and then it gets the fields, and then it generates a method for that field. And the reason that we could do that, that we can just reuse the same function, is because both objects and interfaces both have a name and a list of fields. So we just last time made this enum that just has a borrow of each type and then has a name and a field method. So I think we're gonna do another one of these for union that somehow has the list of fields and types. Then we just have to figure out how to actually build that, because we don't actually have all the fields yet. I think what we have to do is do one more pass through where we find all the objects, and then we just find all their field names and their types. Does that make sense? Object type, name, list of fields, a field that has a name and a type. Yeah. I'm curious though, in like a union, can you put interfaces? Like, can you put the name of some interface here? Union type is similar, but they don't specify any common fields between the types. Concrete object types. You can create a union type of interfaces or other unions. Cool. Yeah, so we basically need to go through the schema once and then build up some object that will then use in case we hit a union type. Let's do that. So what I usually like to do in these cases is, instead of immediately starting to implement this method that will gather of all the types, I like to check that my approach will sort of even work just a little bit. So like our final outcome is that we want to add another case here called a union that has the union type from before. And then some like list of fields. So like a hash map. Object type. It just has a set. No, it's a hash, right? Because we need, for each of the fields, we need the field name and the field type. So it is a string, let's call it name, and some type. Yeah, so the interesting thing here is that since a type in GraphQL is either a named type, that's like it's just user or country, there's the list type, which is then just the brackets list of, and then there's this non-null thing. Our query trails basically don't care about these two. Night, Christopher. Like, our implementation doesn't care about these two, it just cares about this one. Because like if it is a list of country, you're asking for the same fields for like each element in the array or whatever, if that makes sense. So it should be just like a list of name, or like a hash map of name. Use. It's not quite clear like which is the name of the field and the name of the type. It'll be alright. And we need to use hash map. That's in collections. Hash map. And then that is not handled. That is not handled where exactly? Union type, inner fields. Let's just leave this as unimplemented for now. Whoops, we just call it union. is set to fail the build if I have unused variables and stuff like that. Variant is never used, and I also have denied dead code on. Great, very pedantic. So the name. It has multiple names. No, it just has one name. So the name of the type of the query trail type that we want to generate is this name here. So that's inner.name. And we're not using the fields. So it returns a vector of field. So see, this is why we sort of start implementing, like we just sort of pretend that we had the code that could actually build this, and then we try to use it to see if it actually makes sense. Because otherwise we would have spent a whole bunch of time building this hash map, only to realize that it didn't directly work. So it needs to return sort of what this is like, right? I suppose we could just build them, but they need positions. And we cannot stick them in a set because they don't implement hash. And we cannot stick them in a binary tree set either because they don't implement OR. How do you do that? We basically, we need to store all the fields, but check if we already have a field of that name, and then if it then has the same type. Yeah, so I think this is going to be name field. And then when we actually build this hash, when we happen upon a name that we've seen before, we need to get that and then look at the types that each has and verify that they're the same. And if they're not, then throw this compile error that we talked about before. I think that makes sense. So if we have this list, what is he complaining about? Variant is never used. You know what? Let's turn this dead code stuff off. That's annoying. Should compile now. Except that, yeah, so this is the test that we wrote before. So we basically want to return all the values of this set, but flattened. Can you say just values, fields, values? And that returns a values. I have the standard library here. Hash map. Values, can you do that? Nope. Values. This is probably some iterator thing. Fused iterator. Can you collect on that? It probably returns borrows or something like that. I'll use iter. Iter found. So I believe that is because when we like iterate over it, it only returns it has the keys and the values are both borrowed from the map, so we don't own it, which is annoying because it expects that we return like a borrowed vector of owned fields. I guess the dirty solution is to just clone the fields. The performance and the memory sort of optimization of this crate isn't super important because it runs at compile time. It should of course be fast, but I think for now we'll just do it. Does that mean we have to say map field clone? Still not. Is that because we have to borrow it? Nope. Returns reference data owned by the current function. Yes. So we need to return something that lives as long as self does. So in the interest of just making progress, I'm just going to do the dirty thing and call clone here. This doesn't work either. What the hell is this? Is that because we need to remove this one? That seems to have done it. Create some variable which is freed while still in use. That's probably the thing that we talked about in the beginning. Fields. Yeah, so that works. So then later we can think about how to actually remove these clones, or we can be like, meh. We'll see when we get there. I'm not sure how to remove those, because we want to return, like in these two cases, it's just sort of borrowing from this guy, which means that it lives as long as self. But in this case, which is it's borrowed from the hash map. I'm not sure if you can I'm not quite sure what the syntax is, but we can say like self lives for tick A, and there's some lifetime tick B. Is that what it means, that B lives, or A lives longer or something like that? And then we can say like we return something of B. I'm not entirely sure. I'll experiment with that, and then if I figure something out, we can talk about it on the next stream. I think for now, we basically just need to make some progress. You're using explicit closure for cloning elements. I think that's because it just wants us to say clone. Yep. So that means that if we're able to actually build this hash map, then the rest of the code should work. So let's do that. Union. Let's call it union fields map. Type fields map. I guess that makes sense. now it's complaining because the value moves. Like this is a loop, right? And since like this one down here, we take ownership of the map. That means that in the next, like in the second iteration of this loop, the previous value is not owned by us anymore, so we can't give it away again, if that makes sense. That means it needs to be, take B, I guess. I don't think take A will work, because it's generated here. Or does it? I think it does. Because like you would think that, so this tick A here is the lifetime of the document, right? Whereas this one lives not as long. This is one of those moments where it works. So let's just move on and hope that someday we'll see the light. I find this a lot in programming languages, that you'll like try something and either it works or doesn't work, and sometimes you don't understand why. But if you're just able to like power through it and just move on, eventually when you've just had the language into your fingers for so long, things just sort of start to make sense. As you've like written and read enough code, you just kind of get it. Like you get sort of that intuitive feeling about how the language is. So we need another one of these loops, and this time we only care about objects. First, let's say let map hash map new, and return it at the end. It needs to be mutable. We could make this a fold and then like fold the map, but for this I think it's just easier. Like we could do something like iter fold hash map new and then something like that. But for this case where there's like so much matching going on, I actually think this is a bit more explicit. I like taking small steps, so I'm a big fan of like just writing a little bit of code, and then where like the next piece of the code goes, I just put unimplemented, which basically panics, and that's sort of equal to any type. So you don't write 200 lines and then you compile and you realize that you have like 100 compiler errors that you then have to fix. I find that if you write like very small things and you compile often, then you get a much more sort of, it's just much easier that way. It's almost like having a conversation with the compiler in that way. So what we need to do is look at the object types, fields, you say object for field in object fields. Is that because I have to borrow it? I can never remember like when do you need the borrow here and when don't you need it, when you need a moot. Do you ever need it here? Usually I just I write this, I compile, and then I have the compiler tell me what to do. I think in this case it would exactly tell me. So it doesn't like sometimes it's like try putting a borrow here and then it might work. It didn't exactly say that in this case, but it seems to work. Field name and type. So here we probably have to clone again, right? Because oops, we have it here. What we need to return is an owned field and an owned well, an owned key and an owned value, like both are owned. So you can't just say map insert field name and field, because first of all, field is borrowed, and you can't like borrow the contents and then also borrow out the whole thing. So this should definitely fail to compile, and it does. That's a reference. Let's just do the dirty thing here and say clone. Did you see that? Our test passed as well now. So what we're not doing is we're not actually checking if we've seen this field before. So this should work. And this should work as well. And it does. Now let's do the thing where we actually add one more variant to our enum. So we can say that a user can also, an entity can also be a let's use company that like we did before. So the company just has the exact same fields as user, and then we have to go down here, basically add the company. Whoops. Company. Let's just make sure this compiles. So taking small steps. Does still compiles now that the union contains two types. And then let's go ahead and give the company a different field. Let's say this is country of operation. So now we have one field that they have in common, ID, and one field that each that like they have uniquely, if that makes sense. Let's smash this onto single lines. Should still compile. It does not. Field country of operation. Not all trade methods implemented. That's because this method is no longer called field country, it's called country of operation. Small steps. Still works. And let's just try a scalar type name. Name string. We basically don't care like about the implementation of these, we just care that the generated code around it is correct. That seems good. And then up here we should now be able to say name. Whoops, deleted a bit too much. There we go. So now what we need is we need one that fails if this has like country that is then a different type, right? So that is this thing down here. Let's begin by just copying this whole entire thing. Creates all methods for union types fails if types don't match. So let's, like, we don't need this like country of operation stuff. We don't need the name either. Name. And then let's rename say that a company's ID is a string. Which means this method now returns a string. And so now it should not compile. How do you implement that with this approach? Because like in normal tests, you can, like those functions have like a test attribute. You can say like no compile or panic or something like that. Whereas this, can you do that on a whole module? I'm not entirely sure. But we agree, right? This should not work. Like, so both user and country have the same field with the same name, but they're different types. That is allowed when it's a scalar type. Is that correct? Yeah, because we just need to check if you're asking for it. The problem is when it's, if they don't have the same like sub fields. That's fine. So let's actually scroll up, comment out this guy, and just to make sure that that keeps working when they're scalar types. So down here, a company's ID is a string. So let's just make sure the types are right. What did I do? What's wrong here? Field ID has incompatible types. 753. Did we fix the wrong one? Or rather change the wrong one? Yeah. Yeah, that works. So that's a bool. That's a bool. And if you just say country, that is that. That's a bool. We're just making totally sure that the types are generated correctly now. That's a bool. And that is one of these. And if we like make a mistake, it does actually fail. Fixing it makes it pass. So that means you can have scalar types with the same name but different type. That should keep working. So let's, whoops, so much code. Comment out all this stuff. Whoops. Bring this back. So let's just keep the IDs as strings, not to confuse ourselves. Or keep the IDs as integers, rather. And then we'll go ahead and say that they both have a country now. Country. And let's say that this one is actually another country. This means that we need that type. Let's just add that type first. Without actually using it. Whoops. And then we can change this one so that a company's country is one of these other countries. We need to change this to be another country. And this as well. So this is the thing that should not compile, but it does. Because they're both part of the same union. But if you say .country, you don't know what type you're going to get. So this fails because it returns an other country, but I believe that is just simply because that is last in the schema. Like if the concrete variant that's like being used is the user, we don't know if it's this country or this type of country that we want. So that means this should not compile. So we need the type. Like the easy way is basically to loop through the map. So if we say map get field name, so if it's not there, that's fine. If it is there, then we need to do stuff. Object field name. Oh yeah, we need to do this for each field, right? And there's no field. Consider borrowing. That works, and it still compiles, which it should not. Other field. Let's just panic with and just like print out the types. I believe it is field type, yeah. Why did that not work? Consider giving map a type. Oh well, I guess that's because we panic, so it never gets to here. And it can't actually infer what the type is. Name field. Non-null int ID. Oops. Print. So panic at the end. I think it's because it just panics the first time it gets here. So we'll print all of them and then panic at the end. I'm wondering, like, I would like to see the country thing show up. Why does country not show up? Okay. Yeah, we just weren't looking high up enough. So here it is. This, like, all these are fine, right? Because they're the same type. These, on the other hand, are not fine. We already have a country, but they're not the same type. However, that is actually so it is allowed when we build the map. It is only when they're used in a union type that it is not allowed. So I suppose that this map is actually a list of fields. And then if that only contains... does it have to be that complicated? Then it is only a... Like, what I imagine is that we don't want to build this map and then panic here only to never actually have any union types. Because, like, as we see, like, this stuff happens a lot, and it might just be that we have two types with the same field names that are different types, but they don't share a union type. That's of course fine. So I think we have to panic somewhere here. Like, we have to check. It has to be a list. Yeah. Damn it, so close. So let's copy that to the clipboard, but nuke it for now, and say that this is now a vector field. So the way that you can sort of do that, like, if you imagine, we can't just do this, and we can't just, like, insert a vec of that one field, because if it's already there, we want to add to the vector. And so there's this entry API in HashMap, which is really neat. So you say entry for some key, and then you can say, then you basically can get sort of a mutable reference to it, and then you can say or insert nothing, an empty array, and then you can just always add to it. So like it's always there. It's sort of an easy way to handle the case where it's not there. So let's do that. Let's say map entry field name. We had to borrow it. We noticed before. Let entry, and we'll do or insert a vec new. We can just make that vec, and then we can say entry push field clone. I think up here, I think we need a clone though, because it probably needs like ownership of the key, otherwise it can't insert it. Is that right? So that does compile. What is then panicking is this one. That's good. Variable does not need to be mutable. Alright. I'll take your word for it. Use of or insert followed by a function call. That's Clippy. That's giving me these tips. Try this insert with. Let's see what that is. Or insert with default. Or insert with vec field clone. That works, and then we hit our not implemented from before. So now I suppose we need to do the checking here. So we have a union type that has a list of types. We need to loop over those, and for each of those we need to find them in the map, and then we need to loop over all of the fields and see if any of the fields have different types. Does that make sense? No, because if we just loop over a name, no, if we just loop over one of these, that's user. That's stuff like these, right? Yeah. So if we look that up in our hash map, that's not what we're gonna find, because our keys are field names. This stuff is like super fiddly. How do you do that? Does that mean that we need to store like the name of the of like this guy of the object instead. And then a list of its fields. Oh. I think that's what we have to do, right? Sorry, that was my phone. So when we hit a union type, we need to find each of these fields. See if any of them have a field in common where the names are different but the types, where the names are the same but the types are different. So yeah, these names here should be the name of the object. So this should be object name clone. This is why, like, sometimes it's nice if these weren't just like all aliases. But if there are actual like wrapper types, so instead of it being like this, it was defined like this. Because then you wouldn't be able to mix them up in this way. Oops. So now we need to check if that is there. Match field map get union name, none is cool, some fields, then we need to, I guess we need to build like a hash, a set of their names. Field. We can't stick it in a hash because it doesn't implement hash or EQ for that matter. It doesn't implement partial EQ. Why does it not implement full equality? Is that because box doesn't do that? No, it does. Oh well. I'm basically thinking like, how do we check when looping over these fields? How do we check if we've seen it before? For field in fields, we probably need this. No, we don't, because like this is already a borrow, because we're borrowing from the map. We're getting like the reference inside it, and then we're looping over that. So if you took a reference again, then it's like a borrow of a borrow, which is apparently not an iterator. Is the only way, is that to keep a vec of fields, like of names and types? I guess so. Because like hash set, so if we look at like hash set contains, requires that stuff is hash EQ, which field is not. If we use a binary tree set, I believe that requires like yeah, the thing in the set to be ORed, which field is not. So what we need is we need a vec of the name, and this name. Because as we talked about before, we don't care about these two. Previous. So we need to be like, if the previous already contains this pair, then panic, otherwise insert the pair. Let's just call it pair field name clone. So this last bit here is obviously wrong. It needs to be the name of the type. But let's just wait for now. So I believe, let's actually look at it. Source. Basically what we want is we want a method that takes a type and returns like the bottom of that, basically, because as you see, this might be like a recursive data structure where there's types inside types. So we want something that unrolls this whole thing and returns us the bottom name, basically. I believe I have that already. Yes, here, type name. So it takes a borrowed type and returns the name. And it seems that we already use that elsewhere. So that's great. Let's type name. It took a borrowed type, right? Field type. Then we need to say if previous contains pair. Is that the method? Oh, we learned before we can say vec contains. I guess we cannot say that. God damn it. Contains is not a method on vec. Is that because it's on slice? Sir slice. Yeah. So this is a bit tricky, but like all methods that exist on slices also exist on vec, because vec implements deref into slice. So this should work. And it does. Then no, that's wrong. Because if not, if this guy exists before, because if it does, that's fine. It is if it exists, but the type is different, which means it is a hash map. Sorry if I'm a bit slow, but it's kind of late in Denmark. You can see the time up here. Yeah, so it does need to be a hash map. And don't worry, we're gonna somehow like extract this out into its own function when we're done with all this stuff. Let's just say field name, clone, type name, field type. And then it is for hash map, I believe it is contains key. Contains key. Name. No, we're not contains key. We don't care if it's there. We need to be like, if it's there, then do stuff. Other type. If type name is not other type, panic to do. Otherwise, then insert it. So pref insert name type name. Expected bool found option. That's because this needs to be get. Can't compare owned string to borrowed string. There we go. And Clippy is right. Here we can use if let. If let some other type. And it's probably saying that we can do the same thing here. Yeah. But this should fail to compile, right? It did, not quite sure why. No method country. Why is that? It does compile. Why does it compile? think wait, fuck, I'm so stupid. We're getting the union name. We need to do a loop. I bet the people watching at home saw this a long time ago. We need to somehow loop over the types. We're not doing that. Like, types don't appear anywhere. So we don't care about any of this. Like, we do need this map, we need outside, right? And then we need to say for type in union types. Union types. Do you need to borrow? I guess so. This is a name type. Then we'll look that up. Look it up, get its fields, compare with any previous fields, dive, we've seen it before, insert it if we don't get it, and move on if it's not there. Does that compile? It does not. Found vec. That's basically because we don't need the field map anymore, right? No, we do. But it's slightly different because this map is a vector. Like the values are vectors. But what our union thing needs is it just needs like bare fields. So we'll get back to that. And we're basically never using the name here. So this could be a set, but we can't use sets. It really is annoying that field doesn't implement hash. But it should fail. It still doesn't fail. Why doesn't it fail? What is this? Let's print out the previous and do a debug print. And it probably didn't print anything because there's no panic. Whoops. Or we're not even getting in there? We're not even getting in there. Instead, let's print out the type. User company, human droid. That's gotta be some other file somewhere. And then here, field map. See what our field map looks like. Oops, let's actually also print out the type. So this stuff we don't care about. That's some other thing. Human company. User company, sorry. So we get other country, post country, user. Do you guys see it? Here we get the type. We never use it. This is why sometimes I like having this unused variables on, because this should fail to compile now. Yeah, unused variable type. Let's keep that on. Usually when you start making these kinds of stupid mistakes, then you have to consider taking a break. But I really want to finish this. So dead code is cool. Explicit panic, yay! That probably means that we are down here. God damn it! Because it didn't say like panic to do, right? Did you see it? Oh, Mr. Explicit panic. God damn it. Yo. Unused variable fields. See, this is when stuff like this is annoying. Sometimes you want it, sometimes you don't. We do hit that part. For field and fields. Field. So we get company and user, and then we get their fields. Each has one. Country, ID, why don't they each have a country? Is our fields map correct? Type def object. Or insert with. Are we using this method correctly? Or insert. I think we are using it incorrectly. So or insert with takes that, and then that gives you the entry, and then you say entry push. What was it? Field name clone. Is that it? Field clone. So I think like this is just so this is just to sort of save actually, like if we call this method, then it would allocate, or rather it would create a vector every time you call this, even though the key is already there. In which case we wouldn't technically need to, So this is just sort of a minor performance optimization. Because what I noticed was that there weren't a whole lot of types. Like there wasn't that many fields in these. Like, I was curious why each came up so few times. So now there's 4, which is what I would expect. So a user has a field named country where the type is a non-null country. It has an ID that we don't care about. It has so the company also has a country name and a name type other country. So that means this should panic, but it does not. So let's see, type field name field name. Basically, we need a bit more debugging here. Field type. Field type. So it's still at our explicit panic below. I think I will leave off this guy just so we don't have multi-line stuff. Human ups. So both of these should hit, right? No type, name type. Let's print out the names that we're doing the lookups with just to make sure those are correct. ID and country, ID and country. Wait, it did panic at the fuck. So we were looking at the wrong error. Like, I wonder what is this? Like, where does this come from? This is the end-to-end test. Let's comment that out for now. Just fuck it. So this works, and it worked the whole time, and we just wasted like half an hour debugging this. God damn it. So let's make Clippy happy here. If let some fields, then this stuff. So this is correct, it does actually panic. And then let's do the thing where we remove this test, bring back all the others. But we can't do that because this stuff down here doesn't quite work yet. You know what, guys? I think what we're gonna have to do is leave the stream here, because we got pretty far. we basically figured out like how sort of our reference implementation, how Juniper works, and then we wrestled with a whole bunch of stupid mistakes. But I think the foundation is now right to actually fix it and like implement the last stretch. Basically, what we need is we need to build this map down here that we need for this union, right? So somehow this, which in the other map is a vector, it needs to become like just a single field. I'm not quite sure how we're going to do that. I think we can just take the first one from the vector. That should be fine, since we know there isn't any, since we know that they're all the same name and all the same type, because otherwise this would fail. So yeah, if there aren't any questions, I think we're gonna cut it here. Oh yeah, right. And I just saw that you just posted about the debug macro. I do know that, but I don't believe it's not stable yet, right? Is 1.32 out today? Is it out now? How do you see like which version you're using? Rust show 31. Ah, that's sweet. I have been using the debug macro in the past. It's so awesome. I'm really happy that it's finally stable. I have actually in the past like found it in the standard library and just copied the source into my code because I wanted it, because it was so nice. But yeah, I think we're gonna cut it here. If there's any final questions, now's the time. Otherwise, I'm gonna upload the stream to YouTube. So the channel is well, the channel is in the Twitch dashboard, so you can find it there. I don't have like a fancy YouTube URL quite yet. But yeah, I guess the very last thing we can do is just commit our work, even though it doesn't actually work. Work in progress, union types. And we'll also push it up just so we're sure we don't lose it. So yeah, that's it. Thank you for joining the stream. Thank you to Christopher again for subscribing. That's crazy. The next stream, I'm not quite sure when it's going to be. I have quite a busy weekend. Otherwise, it's going to be sometime early next week. But just follow me on Twitter, and I'll post there when the next stream is as soon as I know. Until then, I will see you at the next stream. Let's find the right mouse here. All right, see you guys.